Hi, my name is Debargha, and the paper that I will be presenting today is about design choices for communication interfaces that allow self-driving cars to interact with multiple pedestrians. An external human-machine interface, or eHMI, is typically proposed as a solution for the missing driver-centric communication to facilitate the interaction between self-driving cars and vulnerable road users. However, despite the many proposed concepts, there is no consensus regarding the design of an eHMI. Besides, almost all of these concepts have been evaluated in simple settings involving one car and interacting with one pedestrian. Real-life traffic is rarely this simplistic. Once we introduce more than just one pedestrian in the environment, we can start to see some potential issues. For instance, in this case, there are two pedestrians standing on the side of the road, one at a zebra crossing and another one a bit further ahead than the crossing. When a self-driving car approaches with an eHMI showing an intention to yield to the pedestrian at the zebra crossing, the pedestrian in the middle might intercept the eHMI and mistakenly assume that the communication is meant for them and start crossing. So, at least typical eHMIs that simply announce yielding intention may be a bit problematic in this situation. In our past research, we have seen that to a certain extent, distance-dependent eHMIs can add some more resolution to the message context. If the automated vehicle shows a general yielding intention from a distance and adds more specific contextual information when it comes closer, like where or when it is yielding, it can improve the user experience by clarifying the yielding intention. We wanted to see if this finding can scale and extend to interactions beyond just one pedestrian. There has not been a lot of research in this area on multi-pedestrian scenarios. So to scope the study and reduce the confounding factors, we started with the lowest threshold of multiple pedestrians, that is just two pedestrians. In this scenario, two pedestrians are standing on the side of the road and a self-driving car approaches them. As the car slows down, the pedestrian has to decide whether the car intends to yield to them or to the pedestrian standing further down the road. We tested this scenario out with several eHMI concepts, including some reinterpretation of our distance-dependent eHMIs that we presented in AutoUI last year. I will quickly demonstrate the eHMI concepts. The first concept is the bumper eHMI, which is a light band on the bumper of the car. When the car is cruising, it glows steadily in a bluish-green color. When it communicates yielding intention, it starts animating in a sideways swiping motion. And when it's ready to start driving, it returns to a solid glow again. The second concept adds to the contextual information of the situational awareness to the bumper eHMI that I just showed. Here, on top of the bumper eHMI, the car shows the contextual information of whom the car is yielding to with the visualization on the windshield. In the third concept, besides the bumper eHMI, the car adds the contextual information of an abstract visualization of when the car will stop. As the car comes closer, a display on the windshield illustrates the projected stopping time of the car with a progress bar that fills up by mapping to the deceleration of the car. In the final concept, in addition to the bumper eHMI, the car uses a street projection to show where the car will come to a stop. As the car comes closer, the projection illustrates the exact stopping location of the car. Besides the four eHMI concepts, we also used a baseline condition of no eHMI as a control. So with these concepts, we ran a virtual reality study with 36 participants, with the eHMI concepts as within subject independent variable. We explained to the participants what the eHMI messages meant so that the intuitiveness of the eHMI would not play a significant role. We deployed the study remotely via a Google Cardboard and an Android app due to COVID-19 related restrictions. As the car approached, the participants indicated their willingness to cross in real time by pressing the button on their Google Cardboard. The car approached the participant from their left, about 100 meters away, and exhibited one of three behaviors. It either yielded to them, or it yielded to the other pedestrian further along the road, or it did not yield at all. There was a 10-meter separation between the pedestrians to prevent a feeling of them belonging to a group and to ensure enough distinction between the two yielding behaviors. In both of the yielding behaviors, the eHMI concepts, when existing, communicated this yielding intention. The implicit task of the participant was therefore to interpret whether the eHMI's indicated communication was directed towards them or to the other pedestrian. I will quickly go over the result highlights of the pedestrian's willingness to cross here, keeping in mind the time. I invite you to look into the paper for more details. First, we will look at the condition where the car yields to the pedestrian. Here, the ideal scenario is that participants notice early on that the vehicle is yielding to them, so that they feel safer earlier, they cross the road earlier, and contribute to a more efficient traffic. A high willingness to cross early, therefore, is a potential indicator of a good eHMI. The graph shows a clear distinction between the baseline of no eHMI and the other 4 eHMI conditions. The baseline condition with no eHMI yielded the lowest willingness to cross, and the concept with the street projection shows the highest overall willingness to cross scores, while the other 3 eHMIs score in the middle. It is interesting to focus on the last 2 seconds before the car comes to a stop. While it is not surprising that the eHMI conditions perform better than the baseline no eHMI condition, note that the situational awareness and progress bar concepts did not perform much better than the plain old bumper eHMI. When we look at the average willingness to cross over the last 2 seconds, as shown in this graph, the discrepancy becomes even clearer. So clearly, not all distance-dependent contextual eHMIs performed equally well. We will come back to this later. Now we look at the scenario where the car yielded to the other pedestrian further down the road. Remember that here the participants still saw the eHMI showing a yielding message. Ideally, a good eHMI will clarify to the participants that the car was not yielding to them, but to the other pedestrian, so that they can quickly decide not to cross. So a lower willingness to cross before the vehicle arrives is an indicator of a good eHMI. The graph shows that generally the different eHMI conditions cause very similar responses, and the behavior of the car dictated this response. When we zoom in to the 2 seconds before arrival, we spot some statistically significant differences. We see that except for the street projection concept, all eHMIs triggered a higher willingness to cross than even the baseline no eHMI condition. So once again, not all distance-dependent contextual eHMIs performed equally. Interestingly, some eHMIs inspired even a marginally higher willingness to cross than the no eHMI condition, even when the car was not yielding to the pedestrian, or the participant, I mean. In general, our findings corroborate previous research that eHMIs tend to increase pedestrians' willingness to cross when interacting with an automated vehicle. However, the implications of these findings become more meaningful when we look at them from the context of the scenario when the car was yielding to the other pedestrian. In some cases, eHMIs cause people to have a willingness to cross even if the car intended to yield to the other pedestrian. Thus, the reinforced findings in other research that eHMIs can cause overtrust. However, specifically clarifying where the car would come to a stop, as done by the street projection concept, worked very well. Interestingly, though, the other contextual distance-dependent eHMIs did not perform so well. It could be because even though those concepts added some contextual details, they were not unambiguous and still required some interpretation on the part of the pedestrians. So the most important thing that I want to convey to you in my presentation is that in multi-pedestrian environments, it may be inadvisable for eHMIs to simply communicate that the vehicle is yielding, but specifically and unambiguously communicate to whom it is yielding. How this disambiguation can be achieved in an acceptable way still remains to be seen, but it throws the door open for a lot of interesting research and future work. At the very least, we feel it is important to highlight that simply iterating on the current status quo of eHMIs that show simple yielding intention is not a scalable future solution. I'll close by showing one of my favorite comics of a pedestrian interacting with a self-driving car, thanks to the oatmeal. I'm very sad to say that I'm not able to talk about this paper with all of you in person. I would love to invite you to reach out to me or any of my co-authors. We would love to hear from you and continue the discussion. Thank you very much.